Welcome. In this video, we are going to take a look at problem 3 from chapter 7 of College Physics 2E by Openstax. In this problem, we've got 3 parts. We need to calculate the work done on an elevator car by its cable when the cable lifts at 40 meters at constant speed, and there is friction present that averages to be about 100 newtons. Then we need to find the work done on the elevator by the gravitational force, and then we need to find the total work. All right, let's start with what we know. Okay, we know the mass of the elevator car is 1,500 kilograms. We know it gets lifted, so I'm just going to use a D for displacement here, though we could use H. That's going to be 40 meters. It moves at constant speed. And then the force of friction, since it's moving, I'll use kinetic, is 100 newtons. Okay. And so let's set it up a bit, and then we'll find the works. Okay, so let's draw a free body diagram for the car, and it's moving upward. And we'll say at constant speed. Okay, that means at constant speed, that means the acceleration is 0. All right, we'll define up to be positive. Okay. And so we have an upward tension because a cable is what is pulling it up. So that's going to be an upward tension. We have a downward weight of mg. Since it's moving up, the friction will be down, and I'll just put it to the side. Okay. And then we know the displacement is up. All right, and so if we sum the forces, since it's moving at constant speed, the sum of the forces is 0. Okay, all our forces lie in the vertical. We've got an upward tension, then we've got a downward friction, so we subtract friction, and we have a downward weight, so we subtract that. I'm going to go straight to mg, and that is 0. Okay, for part A, we need the work done by the tension. Okay, and so we can see the tension is going to be equal to the friction plus the weight. So let me add that. So the friction force plus the mg. All right, and so the work done by tension will be the tension times the displacement. The tension is up, the displacement is up, and so we will have a cosine of 0 degrees. Okay, tension is going to be friction plus mg times d, and cosine of 0 is 1. And so the friction is 100 newtons. The mass is 1,500 kilograms times 9.8 meters per second squared. And then we multiply by the displacement of 40 meters. Okay, this gives the work done by tension of 5.92 times 10 to the 5 joules. Okay. Next, in part B, we need the work done by the gravitational force. Work sub G. Work sub G. Okay. So let's remind ourselves that mg is down, the displacement is up, this angle between them is 180 degrees. And so we will have mg for the force times the displacement d times the cosine of 180 degrees. Okay, mass is the 1,500 kilograms. G is 9.8 meters per second squared. Distance or displacement is the 40 meters. And the cosine of 180 is going to give us the minus sign. Okay. Work done by gravity is minus 5.88 times 10 to the 5th joules. Okay, part C, we need to find the total work. Work total. I'll use T for total. So that's going to be the sum of the forces, the total force, times the displacement, times the cosine of the angle between the total force and the displacement. Since it moves up, that would be 0 degrees, but we'll leave it as theta. The total work, the total forces are 0. Right? The total force is 0. When we summed our force, we said it was equal to 0. And that was because it's moving at constant speed, which makes the acceleration 0. So our total work is going to be 0 times a number times a number. Ultimately, it's still 0 times a number, so it is 0, and I'll write out joules. I hope that was helpful. Let me know in the comment section if you have any questions. Thank you for watching, and I'll see you in the next one.